Hello and welcome to Cornerstones of Math. Today we are going to prove the inequality that is actually quite famous, which is this. 1 plus 1 over n to the power of n is greater than 2 and less than 3. This expression in the middle is quite famous since it is the expression used in the limit definition of Euler's number E. Now let's talk about the method. In my opinion, the simplest method to prove this inequality is using calculus, but I am not going to do that in this video. The proof is actually quite easy if you can do some calculus, but here let us take a look at another method that is also quite interesting. Here we are going to expand this part using the famous binomial theorem. The expansion of x plus y to the power of n when n are natural numbers is given as sigma from k equals 0 to n choose k, x to the power of n minus k, y to the power of k. So if we write in expanded form, we first have n choose 0, power of n, then n choose 1, x to the power of n minus 1, y, then n choose 2, x to the power of n minus 2, y square, all the way up to final two terms are n choose n minus 1, x, y to the power of n minus 1, and the final term is n choose n, y to the power of n. So this is the binomial theorem. Now let us apply this to our given expression. So let us expand this. Then by the binomial theorem, we have sigma n choose k, and we don't need to write 1 to the power of n minus k because it is simply 1. So we only have 1 over n to the power of k, which is n choose 0 plus n choose 1 times 1 over n to the power of 1, n choose 2 times 1 over n square, all the way up to n choose n times 1 over n to the power of n. Now n choose 0 is simply 1, and n choose 1 is n, so we have n times 1 over n. Then n choose 2 is n minus 1 over 2, so we have this times 1 over n square, and for the rest, let's just write the same thing. So the first term is 1, and the second term is also 1, and the third term is n minus 1 over 2n. So from here, we have 2 plus n minus 1 over 2n, and if we discard the entire remaining terms, this part is either positive or 0 depending on the value of n. So we have the inequality greater than or equal to. And this is again greater than 2. Therefore, we have 1 plus 1 over n to the power of n is greater than 2. So we have proved the first half of the inequality. Moreover, let's take a look at the expansion of this again. So by the binomial theorem, it is this, and we have already seen that the first term is 1, and the second term also becomes 1. And the remaining terms can be expressed as sigma, now k from 2 to n choose k, 1 over n to the power of k. Now we will focus on this part. Here, the individual term n choose k times 1 over n to the power of k can be expressed as, so this binomial coefficient n choose k is actually n times n minus 1 times n minus 2, all the way up to n minus k plus 1 over k factorial. And this part can be written as 1 over n to the power of k. Here, let's take out 1 over k factorial to the front. Then for the remaining part, we have n minus 1, this over n to the power of k. Now if we take a look at this part, the numerator is a product of total k numbers, and in the denominator, the number of n's is also k. So we can write this part as n over n times n minus 1 over n times n minus 2 over n minus k plus 1 over n. So this n over n is simply 1, and this n minus 1 over n, we can write 1 minus 1 over n. Then we have 1 minus 2 over n, all the way up to 1 minus k minus 1 over n. So this is less than 1, this is less than 1, this is less than 1. So we simply have less than 1 over k factorial. But this k factorial is actually k times k minus 1 times k minus 2, this. So it is less than or equal to 1 over k times k minus 1 when k is equal to or greater than 2. So we have this result. Now back to here. Applying this result, we have 2 plus sigma 1 over k times k minus 1. And we can write this part as 1 over k minus 1 minus 1 over k, which is the trick called partial fraction. Then this part becomes the telescoping sum, which means we have 1 over 1 minus 1 over 2, then 1 over 2 minus 1 over 3, then 1 over 3 minus 1 over 4, all the way up to 1 over n minus 1 minus 1 over n. So these terms cancel out, these terms cancel out. So we have 2 plus 1 minus 1 over n, which is 3 minus 1 over n, which is less than 3. Therefore, we have 1 plus 1 over n to the power of n less than 3, which is other half of the inequality. Therefore, 1 plus 1 over n to the power of n is greater than 2 and less than 3. And the proof is complete. And that's all for today's video. If you liked this video, please hit that like button and also subscribe for more interesting math videos. And I will see you in another video.